the base and the variable part of the exponent. Those are the important parts. That's where you start figuring out what to do. The 1/3 raised to the x.
We're just putting plus 3 for the x and just write it from there. Plus 3 and then have, or yeah, put in plus 3 and then have 2 and 4 for your other points. You have the x, y graph.
No. That won't, that's a little too simple. That won't actually work for this one. No, you got to figure out the points. Well, hey, let me go through the steps. So there may be a shortcut. You may be onto something for a shortcut or a pattern, but let me go through the steps and see if it works. Let me do it the long way first. All right? So looking at just this, and you got to be able to tease this, the base and the variable exponent, out of one of these. Okay, that may be a separate question on the test. What is the parent function of this one? So now, if I go to my usual points, -1 will get you a 3, 0 will get you a 1, and 1 will leave you to 1/3.
They can spell the one out
Yeah.
when you cancel out the other part of it. What was that?
Well, I'm not canceling out the other part of it. I'm looking at a simpler version.
What was I thinking of? Like, what is that called? Is that, like, where does that apply to? You replace x with something that'll cancel out the other number next to it.
I'm honestly not sure. We've done so many things kind of like that. It could be complex conjugates with imaginary numbers. Could be finding the y-intercept. You could be thinking of a couple different things. Right. But I'm not hearing anything that I want to try here. Okay, now, here's how the basic one will look. This is getting shifted by the 3 and the 4 and bent by the 2. So the simplest way to do this is to plug it in. Now, instead of -1, 0, and
you can shift all the x numbers right +3.
yes, instead of -1, Marissa's got it. Instead of -1, 0, and 1, I'm not as interested in that. I'm interested right now in what happens to the x's with this -3. This -3 is the k. K stands sort of for counterintuitive shift. So instead of -3, we add them. So the numbers I'm now interested in are, what's -1 plus 3? 2. What's 0 plus 3? And what's 1 plus 3? 4. So I'm interested in these three numbers. And I'm going to plug these three numbers in to this and see what I get. What is 2 times 1/3? Not quite. To the 2 minus 3 power plus 4. I'm going to work that out over here. What's that equal? 2 to the 1/3. What is 2 minus 3?
1.
-1. What is 1/3 to the -1 power?
10. No, it's the whole thing.
It's just 3. Okay. Now 1/3 to the -1 power is 3. 2 times 3 is 6. Add 4. James, what do we get?
10.
Nicely done, sir. All right. So this one is 10. So this will pass through the point 210. Now we plug in 3, and we get 2 to the 1/3 to the 3 minus 3 power plus 4.
So it's
0. It's 2 to the 1/3 to the 0, yes.
0.
Yeah, what's 1/3 to the 0 power?
1.
1.
So 6.
Yeah, 2 times 1 plus 4, so that equals 6. Okay, and then this one will be, bless you, 2 to the 1/3, 4 minus 3. Ah, someone's got an infinite repeating decimal in mind. Okay, so this will be
4 and 2
2 to the 1/3 raised to the first power plus 4, which is 1/3 to the first power is what? 1/3. Anything the first power is itself. What's 2 times 1/3? 2/3. 2/3 plus 4 is just 4 and 2/3, or as James pointed out, 4.6 repeating forever.
Ms. Bubble,
Yes, sir.
how did you get 10 on the first one, number 2,
problem. We started out by putting 2 in for x, okay? And I got 2 minus 3 up here. That gave us the negative 1 over here.
Right, which has become 1 over.
Well, 1/3 raised to the negative power. A negative exponent means flip the fraction and make the exponent positive after you flip the fraction.
Oh, so it becomes 3 over 1.
And so 1/3 to the negative 1 becomes 3 over 1 to the first power.
Okay, it's just 3.
Yeah.
But if it was just 2 to the, if it was just 2 times 3, it would just be 1/3, right?
If it had been here,
Instead of 1/3, it's just 3, it'd be 1/3.
if it had been 3 to the negative 1, that would have become 1/3 to the first power.
Okay.
Yeah, good. Can't forget your negative exponents. Okay, so now we got to graph these 3 points. May I erase this work here?
No, you may not.
Thank you, Layla. Anyone still writing this down, however? Okay. Then I will graph those 3 points. And there's one more thing you'll have to keep track of, which is, okay, I'll get to that in a sec. The asymptote. Very good, Marissa. Okay, so the points are 1, 2, 3, 4. Okay? At 2, we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At 3, we have 6. 1, 2, 3, 4, 5. Can't count this morning. And at 4, we have 4 2/3. I'm going to go up to 4. Go a little bit.
Oh, no, you're at 5.
I'm at 5? You're right. You need to go down a little bit. Wow. Amy, that's a great eye for my lousy scale. Okay, now, before you graph it, there's one more thing I insist you do. Okay? I said that on exponential decay, the x-axis is still an asymptote. What do you think this plus 4 does to that? Raises the asymptote up 4, so now we have to draw a dotted line here, indicate that it's the line y equals 4, and when I draw my exponential decay, I cannot go below that line. If you draw this graph and go below y equals 4, I'll know you missed the asymptote part, and you have done it wrong. Not the best drawing in the world, but it works. You got to remember the asymptote part, because if you go below it, you've missed on your exponential decay. Questions, comments, concerns, compliments? Excellent. That's it. I'll tell you the homework in a minute. Cody?